So let's solve this problem by applying our template. So first of all, let's read it carefully. A fish swimming in a horizontal plane has velocity given, and the point in the ocean whose displacement from certain rock is, so displacement also given. After fish swims with constant acceleration for 20 seconds, its velocity becomes new velocity given. And what are the components of the acceleration? So first question, what are the components of the acceleration? So first step is framing. Let's draw roughly. This is a vector because velocity is given in terms of unit vector, so direction is very important. What else we can say about this problem? Vector velocity is direction approximately like this, because x component positive, y component also positive, so it's moving initially in this direction. And what we have initial displacement. So in horizontal direction positive 10, in in vertical direction minus 4. It means this point, initial point, is located somewhere here. So this is our y and x axis, 0. So x component is positive, x displacement, vertical y displacement is negative, so it's somewhere here and it's moving in this direction. And after 20 seconds velocity becomes 20 in x direction and negative 5 in y direction, so it means it will be moving approximately in this direction. This is a direction of the motion, but I'm not sure about its position because we don't know for now. What else? And this is a motion with constant acceleration. It means this is very important. I think that's enough for now. Initial velocity is given, final velocity given, initial position given, time given. Basically these are the given physical quantities. We have 4 physical quantities given, so we need to find acceleration, and this acceleration is constant. As the planning, I would say that we can use all equations that belongs to the motion with constant acceleration. Let me write it here. We are still planning, so we can use these equations because we know that it's motion with constant acceleration. And also velocity displacement vector quantity, so likely we can use component methods, vector component methods, because all physical quantities given in terms of components. So roughly this is what we planned. This is our frame. Now let's try to apply, let's try to solve by using our this planning. So we can apply these 3 equations in both x and in y direction, because this is a component. This is what we already planned. So first of all, let me use first equation, because velocity given, final and initial, time is given, so I think we can find our acceleration by using this equation, but we need to apply it in both directions, in x direction and also in y direction. So let's start with x direction. So velocity final in x direction equal to velocity initial in x direction plus acceleration in x direction times time. Final means velocity after 20 seconds. Initial means the initial velocity, basically. So in x direction final velocity, as you see from the problem, it's 20, positive 20. Initial velocity in x direction 4 plus acceleration in x direction unknown, time after 20 seconds. So basically 20 minus 4 equal to 20 times ax, 16 equal to 20 ax equal to 16 over 20 equal to 0.8 meter second square. And let's apply the same equation but in vertical direction, in y direction. So in y direction, v final in y direction equal to v initial in y direction plus acceleration in y direction plus t. So final velocity, as you see, -5. Negative means it will be moving downward. -5. Initial velocity is +1. Ay unknown. Acceleration in y direction times time 20. So -5 minus 1 equal to 20 times ay. -6 equal to 20 times ay. Ay equal to -6 over -6 over 20. It's 0.3. -0.3 meter per second square. So this is a components of the acceleration. We already answered for the first question. So if you remember, in our template we need to check. So we solved the part A, so let's check it immediately. We know that after some time it will be moving in this direction. Yes, this is initial direction, this is the final direction. So it was going up. After 20 minutes it will be going downward. It means we have an acceleration downward basically. Yes, so we expect negative acceleration in vertical direction logically. So I think we solved it in correct way because our acceleration in vertical direction is negative here. It means we did it in correct way. So let's come to the part B. Part B. What is the direction of the acceleration with respect to the unit vector I? So I is the horizontal direction basically. This is a as you see, ax, acceleration in x direction is positive. It means it's accelerating in x direction to the right. Y direction is negative, so this is the direction of the acceleration basically. And what is the direction of the acceleration with respect to the unit vector? I think we need to find this angle. This angle, theta. We can first find this angle, then 360 minus this alpha will be answer, because this alpha is easy to find it. This is ax, this is ay, so this part is totally mass geometry. So as you see, tangent alpha equal to ay over ax. Just we will pay attention to the magnitude, to the length basically. 0.3 over 0.8. From here alpha equal to tangent minus 0.3 over 0.3 over 0.8. Angle will be equal to, let's use our calculator. It says angle equal to 20.5 degrees. So this angle theta equal to 360 minus 20.5, so it will be equal to approximately 339.4 or 5 degrees. So this is the direction of the acceleration basically. Now let's come to the last part, question part C. So we need to find position of the fish after 25 seconds if it keeps moving with the same acceleration, these accelerations. So position, So we will come back to our three equations. We have a position information in second equation and in third equation. So now we should decide which one will be more convenient, more easy for us to use. I think it's the last one, because we have a time here. We should find its position after 25 seconds. In second equation there is no time. So first of all we need to find final velocity, then we need to find position. We can waste some time. But by using the last equation, we can directly, quickly find the position by using just one equation. Again, this is a vector. So first of all, let's write in x direction. Final position equal to initial position plus initial velocity in x direction times time plus 1/2 acceleration in x direction times time square. So you should be careful. This one is displacement, which is final position minus initial position. You should remember. So here I wrote it in terms of position. Or we can say here subtract, here equal. It's totally same. It's totally same. Yes. So final position in x direction unknown. Initial position in x direction equal to 10. Positive 10. Velocity in x direction initial positive 4. Times time 25. Plus 1/2 acceleration x direction 0.8 times 25 square. Further is just a matter of mass. 10 plus 100 plus 0.8/2 times 25 square, 250. So final position equal to 250 plus 100 plus 10, 360 meters. This is its position in x direction after 25 seconds. Same equation we need to apply in vertical direction. So y direction. Final position in vertical direction minus initial position in vertical direction equal to initial velocity in y direction times time plus 1/2 acceleration in y direction times time square. Final position unknown, initial position -4 minus 4. Initial velocity in vertical direction, as you see here, +1 times time 25, 1/2, acceleration -0.3 in vertical direction times 25 square. So equal to 4 plus 25, -4, yes. Here it will be positive. If we take it to the other side of the equal, it will be negative. Minus here 25 square times 0.3 over 2, 23.75. So final position equal to 25 minus 4 minus -72.75 meters. So final position in vertical direction equal to -72.75. So we found its position after 25 seconds. But we didn't finish because it's asking for direction. This is not direction, be careful. This is its position. So it will be passing from these coordinates. That's all. But we don't know its exact direction. Maybe it will be moving to the right, to the left, I don't know, to up or downward. This information is missing here. We need to solve, we need to find it. So now let's find its direction. Time is given, initial velocity is given. It means we can use again our first equation in both directions. In x direction, final velocity in x direction equal to initial velocity in x direction plus ax times time. Initial velocity in x direction 4, ax 0.8 times 25. So velocity in x direction equal to 0.08 times 25 plus 4, 24 meters per second. Positive 24, it means it will be moving to the right in x direction. So let's apply the same equation in vertical direction. Final velocity in vertical direction equal to initial velocity in vertical direction plus AYT. Initial velocity in vertical direction equal to 1. Acceleration is -3 in vertical direction times 25. So final velocity in vertical direction equal to -0.3 times 25 and a plus 1. So answer is -6.5 meters per second. As you see here, we have a negative velocity. It means it will be moving downward. So this is the direction of the velocity. X direction positive, vertical direction is negative. So again, we need to find this angle. Let's call it beta. X component is 24, vertical component 6.5, the magnitude. So tangent alpha equal to 6.5 over 24. We are not paying attention to the signs because we know beta is this angle. So from here, alpha equal to 15.1, approximately 15 degrees downward. This angle below the horizontal direction, 15 degrees. So this is the direction of the motion. So now let's try to check it. Is it possible? Is it correct? So we know that after 20 seconds it will be moving in this direction. So after 25 seconds, likely it will be still moving in this direction, approximately downward, right and downward. So we have a same answer, similar answer, I mean same direction. So I think we did it correct.